Some congruent triangle questions to start with. First one, these triangles look exactly the same, but it says they're not to scale. So we can't use a ruler and measure them or anything. They could be, for example, they could be like this, and that could be to scale. And in fact, that's essentially the answer to the first question. Are they definitely congruent? No, because essentially we have angle, angle, angle here. The angles are the same, but that does not imply congruency. It implies similarity if for the angles in a triangle are the same, but we're being asked about congruence, whether they're exactly the same size. You can rotate them and everything for congruence, but yeah, they have to be the same size. So no, because the corresponding lengths could be different. I think that's enough for 1 mark, but I'm just going to clarify it and just say e.g. E.g. one triangle could have lengths double the other one. Good little test on whether you understand congruency. Right, then we're asked to prove that these two triangles are congruent. And again, they look exactly the same, but they're not to scale, so we need to be a bit more careful. I've got to be honest, I still sometimes forget my rules of congruency. So I think every time you do a congruency question, it's just good to recap what implies congruency and also what does not actually. And here we go. So SSS implies congruency if you have 3 sides of the triangle the same. SAS also does if you have a trapped angle in between the 2 sides. Then angle, side, angle if you have 2 angles and a trapped side. I think these are the 3 easiest to remember because you just remember all the sides the same. Going along with that, remember that angle, angle, angle does not imply congruency. And then if you have this trapped angle or trapped side, then it also implies congruency. The next one to remember, that's probably a bit trickier, easier to forget, is that angle, angle, side also implies congruency. If you have an angle followed by an angle followed by a side, then it does. I'm not proving that here, but it is a fact and it can be proven. And then we're left with RHS, that's when you have a right angle, a hypotenuse, and a side. That also implies congruency because of Pythagoras' theorem, essentially. You can work out the other missing side, and then you'd actually have side, side, side. So it's enough to just have RHS. This leaves one that's worth looking at, and that's side, side angle. And this is not sufficient for congruency. It might be that they're congruent, but when we're talking about congruency, we mean it has, do we know for absolute certainty whether it is? And if you're just given side, side angle, you don't. If you're given 6, 11, 30, there are actually 2 triangles that can be drawn. So you just need to be aware of that. They've drawn one up here, and the second one would look like that. And you get one with let me just look. You get one where the angle is obtuse and one where the angle is acute. And I'm not going to get into any more detail on that now, but it can be shown using the sine rule, in fact, that you can get 2 solutions. But no more detail on that. Just be aware, I think, that side-side angle does not imply congruency. There's a special case of side-side angle, in fact, and that's when the angle is 90 degrees. So this one here is actually a special case of side-side angle, but it's okay in that case to say that they are congruent. So be aware of these 5 cases where congruency is definitely occurring, and then angle, 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 which is not sufficient, and side-side angle, which is not sufficient either. Right, gone into some detail there, but it's worth just recapping that every time until you become really confident with congruent triangles. It does feel sometimes like it's just a list of rules that you're learning, but it's better if you understand it, which means you need to go into a bit more depth on the topic than I'm doing so now. So where are we with this question? Well, what's jumping out at me is the side angle side congruency rule because I've got this trapped angle. So I just need to basically make it really clear. I can't just write side angle, done. It's a 3-mark question. I need to do a proof really carefully. So what am I going to do? I'm essentially going to show that side angle is the same. So GH is equal to JK. That's me showing that the corresponding sides are the same here. And then angle HGI is equal to angle KJL. That's me saying that these 36 degrees is the same in both. Because I'm talking about this one, the middle letter is the angle you're interested in. You're just making it clear what angle you mean. Because if you said angle, like I think it's clear in this case and you get away with it, but if I suddenly started having lines coming off, it's less clear what angle G is, but it would still be clear what angle HGI is. And then finally, we've got the side GI is equal to side JL. And I've done my 3 things that I need to. I just need to say, I've kind of run out of room here, but by SAS, the triangles are congruent. So make sure you include this final statement as well. Okay, one of the more technical questions on GCSE, but once you know the rules and you learn how to make these proofs, it's not as bad as it might first seem.